Okay, today we're going to start looking at functions. I want you to think back to 5th grade where you might have had something like this called a function machine. And in the function machine, you would first establish a rule or put some sort of rule here, like we're going to plus 5. And what that means is that we're going to put something in to one side of our machine. This rule is going to be applied, and what comes out is going to be the result. For instance, if we put 2 into the machine, it comes into the machine 2 plus 5, and then what comes out is 7. So today we're going to look at input-output tables, which are using this concept of a function machine. There are 3 representations of a function. We're going to work on this one today, which is tables, but they're all also rules and graphs. And if you notice, there are double arrow lines in between each of these representations because a function is represented in these 3 different ways. Okay, a function, by definition, is an input-output relationship that has exactly one output for each input. This is extremely important, exactly one output for each input. You have 2 variables. You have the x variable, which is your input, and it's also in algebra called the domain, and it is independent, which is going to make a lot of sense when we start to graph. The other variable is the y. That's our output, or our range, as it's called in algebra, and it is dependent. Again, independent and dependent will make more sense when we start graphing. Input-output tables can either be vertical or horizontal. So vertically, they would be set up this way, where your input or your x value is in one column, and your output or your y value is in the other column. You need to be careful with horizontal tables. This one below is horizontal. You need to notice that the input tends to be on the top and the output tends to be on the bottom. All right, let's actually create an input-output table now. And we're going to use this as our function. Y is equal to x minus 1.5. So looking at my table, my input or my x's are listed here in the first row. What that means is I'm going to put my 2 or substitute my negative 2 where x is, and I'm going to do the math out. So I would have negative 2 minus 1.5. Negative 2 minus 1.5 would be negative 3.5. Now, let's get rid of this. And instead, now I'm going to insert negative 1 for x. So I have negative 1 minus 1.5 would be negative 2.5. And then we're going to insert 0 for x. So I'll have 0 minus 1.5, and 0 minus 1.5 is negative 1.5. And let's get rid of that line now and insert a 1 for x. So I'd have 1 minus 1.5, which would be negative 0.5. And last but not least, we're going to plug in 2 for x, and I'll have 2 minus 1.5. And 2 minus 1.5 would give us a positive 0.5. All right, let's try one more. In this one, our function is y is equal to 2x plus 3. And if you notice, I didn't select anything for my input yet. Sometimes it's not given to you, so you get to choose. And I have some favorites that I like. I like 2, 1, 0, and -1. And when we go to graph, you'll see why I like these the best. Now, I have my inputs. What I'm going to do is take each of these numbers, and I'm going to plug them in for the value of x. And I'm actually going to write them here so that you can see what the expression looks like, and then we'll solve it. So the first one would be 2 times, and instead of x now I'm going to put 2, plus 3. And 2 times 2 is 4. 4 plus 3 is 7. So my output, or my y value, is 7. Now I'm going to put in a 1 for x. So I have 2 times 1 plus 3 is equal to, 2 times 1 is 2, plus 3 is equal to 5. Now I'm going to put in a 0 for x. So I'm going to have 2 times 0 plus 3. And 2 times 0 would be 0, plus 3 would be a 3. And lastly, I'm going to put in -1 for x. So I will have 2 times -1 plus 3 is equal to -2 plus 3, which is equal to a 1. Now, if you notice, give you a little preview for the next lesson, for each of these going down by 1, my output is going down by 2. So there is a pattern both in the values for the x's and also a pattern in the value for the y's.